Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the first part of the series of CSIR NET Physics 2021 paper solution. Okay, so and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details to your friends as well, so that they will also be able to watch my free lectures and and will be benefited from it. Okay, so let's get started. First question of the day of CSIR NET Physics 2021 paper solution. Okay, so question number first is, so I'm solving part B questions first. Okay, so which of the following, it's a good question and simple question actually, which of the following, which of the following two physical quantities, two physical two physical quantities cannot be measured, cannot be measured cannot be measured simultaneously, with arbitrary accuracy, arbitrary arbitrary accuracy for the motion of for the motion of a quantum particle, of a quantum particle in 3D, in 3D, three dimension. Okay, 3D or three dimensions. Okay, options are given. The option is the square of radial position and z component of angular momentum, means this is given r square and lz. Okay, option B is x component of linear and angular momenta, right? So this is x component of linear momentum is this, and angular momentum is Lx, right? And option C is given y component of position and z component of angular momentum. Okay, y component of position means y, and z component of angular momentum means Lz. Okay, and option D is square of the magnitudes of linear and angular momentum, means p square and l square. So square of linear momentum and square of angular momentum. So this is the question, guys. Okay, so I'll read the question. This is let me just check whether I'm audible or not, then I'll proceed further. Yes. LZ. Okay. Option B is X component of linear. Yes, I'm audible, so I'll proceed further. Okay. So question is very simple. It is asking which of the following two physical quantities cannot be measured simultaneously with arbitrary accuracy. Okay, for the motion of a quantum particle in 3 dimensions. Okay, so very simple. So will what we are going to do is will find commutation of these four, right, commutations, and if commutation is 0, then they can be measured simultaneously, and if commutation is not equal to 0, then they cannot be measured simultaneously, right? So we'll check option by option. Okay, first option is first option is r square and lz. Okay, this is, so we'll check the r square and lz, right? We'll check the commutation of this, we'll check it, right? So r square means, you need to understand, r square is x square plus y square plus z square comma lz, right? Because we know r is position coordinates, that's x I cap plus y j cap plus z k cap, right? So the mod of r square is going to be mod square of r, or r square is going to be this one, right? Now we'll use commutation property, we know it, right? So this is going to be x square comma lz commutation plus y square comma lz plus commutation of z square comma lz. Okay, so now what we are going to do is we'll use commutation property, that is x, you can write x square, x into x lz, plus y, we can write y into y ly lz, plus we can write z into z lz, right? And then we'll use commutation property, right? This property, guys, I'll show you. This is this one, a dot ab abc, this property. Okay, this is going to be a commutation of bc, okay, plus plus ac commutation of b, right? This property we are going to use it here. This property, we know, I have explained in detail in my quantum mechanics lecture. So I would suggest you check my that lecture, quantum mechanics lecture. Okay, so this is going to be x lz plus this is going to be x lz, okay, and then this is x lz x. Similarly, this is going to be y lz plus y lz y, and here this is going to be z lz plus z lz z outside. Okay, this is the one. So we have just simply used this property. I can show you. This is abc equal to abc commutation of abc plus ac commutation of acb. Okay, this property we have used. Okay, so now we know this x lz, this value is going to be 0, this value is going to be 0. Okay, no, this value not going. This is x lz, so this value we should know it. Okay, I'll show you. So here we know x lz value is going to be minus iota h cut l sorry, minus iota h cut y. It is not in cyclic order, right? X then z. If it would be like this, lzx, this is cyclic order, right? X, that zx, right? Then it is going to be iota h cut y. Okay. Similarly, this one, ylz is going to be y commutation of y lz is going to be this one. This is in cyclic order yz, right? So this is going to be iota h cut y and z is here lz, right? So x. Okay, so in this way we'll put the value here. So this r square lz lz is going to be the first one is this one. Okay, x lz, this is y lz. Okay. Z square lz is going to be 0, guys, because they are same, right? That's fine. So this value is going to be 0 because they are same component, right? Z component. So this value is 0. This value is 0. So this one. So now this value is going to be this one. So this is xz, right? So x minus h cut I h cut y, and second is going to be plus this one x lz, right? So this is also the same. This one, but I this. Okay. So this is minus iota h cut y x plus third one is going to be y, this one yz. It is in cyclic order. So I h cut x plus this one I h cut y I h cut y I h cut xy I h cut xy, right? So this value is going to be 0, right? This is minus iota h cut xy plus this is also minus iota h cut yx. This is iota h cut yx. This is plus iota h cut xy. This will cancel this. This will cancel this, right? This value is going to be 0. So the commutation is r square lz commutation is 0. It means they commute means they can be measured simultaneously. So this is not the answer, guys. So it is asked which cannot be measured simultaneously. Okay. Next option will check px and lx. Option B, ex and lx. Ex and lx. It's very simple, guys. You should know it. Okay. This value is their commutation is 0, guys. Px lx, you should know it. Okay. Px lx, the commutation is 0. So this cannot be. Okay. Option C. Option C is option C is ylz. Okay. Ylz. ylz. So ylz. So we'll find the commutation ylz. we know the LZ commutation. Okay. Why LZ commutation we know, I already explained. So why LZ means this is y LZ, right? And this is in cyclic order, so I H cut x. So this is not equal to 0. Means this is the correct answer. And if you check option D, option D is p square L square. Okay, p square L square, and we know the commutation of p square L square is also 0. This you need to know. This is px Lx is 0 and p square L square equal to 0. Okay, so this is we can see the answer of this is y Lz equal to iota h cut, and which is not iota h cut x, which is not equal to 0. So option C is the answer. So this cannot be measured simultaneously. Okay, if commutation is 0, then they can be measured simultaneously. Okay, very good question. Next question we are going to solve. Next question. So I have explained all the properties of commutation in my quantum mechanics lecture. So I would suggest you please watch my quantum mechanics lecture. Okay. Now question number 2. Question number 2. This is also a good question. Okay, and I'll solve it by trick. So you can easily solve it by trick. Okay. So here, a particle in one dimension. Question 2. A particle in one dimension a particle in one dimension executes oscillatory motion oscillatory 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 motion in a potential Vx equal to Ax, A mod x. Okay, where A greater than 0 is a constant of appropriate dimension, constant of appropriate dimensions if the time period t if the time period t of its oscillation t of its oscillation depends on the total energy E, the total energy E as e to the power A, then the value of A is okay. Options are given. Option A 1/3, option B 1/2, option C 2/3, and option D 3/4. Okay, so this is the question, guys. Okay, just give me 1 minute, guys. There is some issue. Okay, so this is the one. Okay, this is the question, guys. Okay, the question is a particle in one a particle in one dimension, particle in one dimension a particle in one dimension executes oscillatory motion in the potential disk. Okay, particle is in 1D, right, and executes oscillatory motion, and potential is Vx equal to A mod x, where A greater equal to 0 is the constant of appropriate dimensions. Okay, if the time period of its oscillation depends on the total energy E as e to the power A, then the value of A is, okay, then the value of A is that's what you need to find. Okay, so I'm going to solve it by trick. Okay, so we have given potential, guys. So we have given potential Vx equal to A mod A mod x. Okay, A mod x, it is given. So this, from here we can see what is the power of x. We just need to check power of x. So power of x is 1. So uh, m equal to power of x, that is m equal to 1. We can write this, right, A x to the power 1, right? So m equal to 1. So here what we need to find out, we have to find this one. If the time period of oscillation is t, okay, that is its oscillation, if the time period t of its oscillation depends on total energy, then we have to find the relation dependency of e and t time period, right? And then we need to find the value of a. Simple. So there's a trick, by trick, because m equal to 1, right? So here by the trick, J, that is L, angular momentum. Okay, J is going to be proportional to e to the power m plus 2 upon 2m. Okay, this you need to note down. The angular momentum is proportional to e to the power m plus 2 upon 2m. Okay, so from here we can find J, value of J is going to be, value of J is going to be proportional to e to the power m is this, m is 1. So 1 plus 2 upon 2m, right? So J is going to be proportional to e to the power m is 1, right? So 2 into 1, 2 into 1. Okay, so this is going to be e to the power 3 by 2. Okay, so J is proportional to e to the power 3 by 2. It is the angular momentum. Okay, this trick you need to note down. Okay, if V is given, if Vx is in the form of x to the power n, right? Or here, and if V is if V power, if x to the power is something else, right? If Vx is a x to the power 6, here m equal to 6, right? Then J value will be according to this potential. Okay, I hope you have understood it, guys. So by trick we have found value of J. So it, or we can write J equal to some constant, let's say x naught e to the power 3 by 2. We can write it, right? And so from here the value of T, this is a formula you need to note down. T is, value of T is value of T is del J upon del E. Okay, very important formula. T is the relation between time period and angular momentum is del J upon del E. Okay, so from here we can write value of T. Value of T is going to be del J. Del J is this, right? So this is d upon de. J value is x naught e to the power 3 by 2. So from here T is going to be equal to x naught into 3 by 2 e to the power n minus 1, right? 3 by 2 minus 1 by 2. So this is e to the power 1 by 2, right? So now you can see t is proportional to e to the power 1 by 2. Okay, t is proportional to e to the power 1 by 2. Simple, right? T is proportional to 1 by 2. Okay, so from here we can say this implies value of a is 1 by 2. That's what we need to find right here. So t is this one depends on the total energy e to the power a, right? And value of a. So we can see t is depending on e to the power 1 by 2. So value of a is 1 by 2. Okay, so this is the answer. So which option is matching, guys? So you can see by trick we can easily how quickly we have solved this question, right? So this is j proportional to e to the power m plus 2 upon m, right? This one. So this is important relation, guys. Okay, so which option is matching? So which option is matching, guys? Option B is the correct option. Okay, 1 by 2. Very simple by trick. I have already told you the trick for this. E is proportional to n to the power 2m plus 1. 2 m to the power 2m upon m plus 2, right? In case of simple harmonic or oscillator, and if v is in the form of x to the power something, right? Similarly, there is a trick that j is proportional to e to the power m plus 2 upon 2m, right? So just put the value and you've got this value, right? And there is a formula, time period equal to del j upon del e, angular momentum upon del j upon del e, right? We just have put the value, differentiation of angular momentum with respect to e, and we've got the value t is proportional to e to the power 1 by 2. So it means value of a is 1 by 2. I hope, guys, you have understood it. Very simple. Next question we are going to do. Question number 3rd. Question number 3rd is, it's also a good question. Question number 3rd is, the components of electric field the components of the electric field components of the electric field in a region of space in a region of space, okay, devoid of any change, okay, devoid of any change or current source current sources, means there is no charge, okay, sources are given to be are given to be are given to be are given to be EI equal to AI plus sigma j equal to 1 2 3 b bij xj, okay, where ai and bji bij are constants independent of the coordinates the number of independent components the number of independent components of the matrix bij is, okay. Options are option A 5, option B 6, option C 3, and option D 4. Okay, so this is the question, guys. I'll repeat it. Okay, the question is, the components of electric field in the okay, so this is the components of the electric field in a region of space devoid of any change or current sources. Okay, so there is no so devoid of any change or current source means there is no change and there is no current source, means there is no charge available. Okay, are given by this. So components of electric field are given by this ei equal to ai plus ej equal to 1 j equal to 1 to 3 bij xj, where ai and bij are constants independent of coordinates. Okay, the number of independent components of the matrix bij is, that's what we need to find out, guys. Okay, so it's a good question. I'm going to solve it. So we have to find the number of components of the matrix, okay, bij. So let's solve it. So guys, we have been given ei is given equal to ai plus sigma j equal to 1 to 3 bij xj, okay, bij xj, okay. Okay, so we can see this this equation represents a set of 3 equations, right? So this equation represents a set of 3 equations. This equation represents a set of 3 equations. Set of 3 equations. Okay, so we can write E1 is going to be, we'll write this set of 3 equations. So E1 is going to be A1 plus this B11, okay, plus B12 plus B13 x3. This is x3, this is x2, B11 x1, B11 x1 plus B12 x2 plus B13 x3. Okay, right, we have put the value of j, okay, 1 to 3, and ai equal to, taken a equal I equal to 1. So now E2 is going to be A2 plus B22, sorry, B21 x1 plus B22 x2 plus B23 x3, B23 x3, right? And E3 is going to be I equal to 3, right? So A3 plus B31 x1, B31 x1 plus B3 B32 B32 x2 B32 x2 plus B33 x3 B33 x3, okay, B33 x3, right? So this is the equation, you can say 1, right? So these are the, so this equation represents set of 3 equations. So this is the equation, right? Now our aim is to find out the number of independent components of matrix Bij, okay? So now now here you can see this E1 equal to Ex and E2 equal to Ey and E3 equal to Ez, okay? These are the x, y, z components. Yeah? So this we also we can write, right? Let these are x, y components. So Ex equal to E1 we can write, and Ey equal to E2 and E3 equal to, and E3 equal to Ez. We can write, okay? Or we can write this Ez equal to E3. Ez equal to E3, okay? Ez equal to E3. So then equation is going to be this one. Ex equal to Ex equal to A1 plus B11 x plus B12y B12y plus B13 z. Okay, we have just written this, okay? This one, E1 equal to x, E1 equal to Ex, E2 equal to Ey, E3 equal to Ez, okay? And x1 equal to x, y, x2 equal to y, and x3 equal to z, okay? Yeah. And x1 equal to x, y1 equal to y, and z equal to, sorry, E1 x1 equal to x, x2 equal to y, x2 equal to y, and x3 equal to z. So we have done just, we have replaced x1 by x, x2 by y, and x3 by z, and E1 by Ex, E2 by Ey, E3 by Ez. These are same things, okay? So similarly, we can write Ey equal to A1 plus B21x, B21x plus B22 B22y plus B32z, B23z, okay, B23z. Ez equal to A3 plus B31x plus B32y plus B33z, okay. So these are the set of equation. We can say equation number 2. Now guys, for electrostatic field we know, right? For electrostatic field del cross, there is no charge, right? Del cross E equal to 0. Del cross E equal to 0 means this one, del cross E, right? This is, we know, x cap, y cap and z cap. This is del upon del x, del upon del y, del upon del z, right? And it is ex, ey, ez, right? We can write, and this equal to this determinant of this, right? This equal to 0. So now what we can do, we can solve it one by one, okay. Let's just look at x component first, okay, which will be equal to 0, okay. X component which will be equal to 0. So x component means this one goes this rows and this rows goes this one, right? Del z upon del y for x component, okay. So del z this one for this, okay. This line get cancelled, this line get cancelled. This is del ez upon del y, del ez upon del y equal to del ey upon del z. Sorry, minus, my apology, it's minus, and that component is going to be equal to 0. That component is going to be equal to 0, right? So now we can differentiate it, because we have ez, this is the ez, guys, okay, ez, and this one del ez upon del y, so we'll differentiate with respect to y, ez, right, y. So only this component will remain, so B22. So this is going to be ez, this is B33, right, this one, y, B32. So B32 minus del ey upon del z, del ey means this one, del ey upon this one, del ey upon del z this. So B23, right, difference B23, that is going to be equal to 0, okay. So what we are going to do is, where x component will be equal to 0, right? This is the x component. So from here B31, B32 equal to B23, right? And similarly we can do that y and z component equal to 0, right? So similarly we will get from y and z components B13 equal to B31 and B12 equal to B21, B12 equal to B21, right? So B1, so now B13 equal to B31, B12 equal to B21, and this is B32 equal to B31. Okay, this is the relation we have got. So this means that means Bij equal to Bji, right? So that implies Bij matrix is symmetric. Bij is symmetric matrix. Bij is symmetric matrix, right? So Bij is symmetric matrix means we know the property of symmetric matrix. If it's a symmetric matrix, it will have 6 independent components. Okay, so we know symmetric matrix. So a symmetric matrix will have I have explained symmetric matrix in detail in my mathematical physics lecture, so please check that. Okay, a symmetric matrix will have three diagonal plus 3 off diagonal 3 diagonal plus 3 off diagonal, that is 6 independent components. Okay, independent components. So symmetric matrix will have so they have 3 diagonal independent components and 3 off diagonal independent components, right? So total 6 independent components symmetric matrix have. Okay, for 3 cross 3 matrix. Okay, so it means so now we have because it's so we can see that the region is charge free, right? It is given in the question, this statement, right? Electric field in the region of space devoid of any change or current source. Okay, so current source means there is no charge. Okay, devoid means without, completely without. Okay, so it means so it means we'll write also, I'll write in next page, also as the region is charge free, therefore del dot E is going to be 0. Del dot E is going to be 0 because of charge free, right? So this implies del Ex upon del X, the dot product, right? Del Ey upon del Y plus del Ez upon del Z equal to 0. Okay, this is equal to 0. Now we'll put value of del Ex del Ex upon del X upon del Ey upon del Y plus del Ez upon del Z, right? Because we can differentiate it. We have Ex, Ey, Ez value, right? We'll differentiate it, the Ax with respect to X, Ey with respect to Y, Ez with respect to Z, right? So if we differentiate it, so this going to give value, that is B11 plus B22 plus B33 equal to 0, like del Ex upon del X, right? So you can del Ex upon del X, right? This is a constant, this will be 0, these will be constant, this will be 0, this is going to be B1, right? So B11 plus B22 plus B33 equal to 0. If this is the case, okay, if B11 and plus B22 plus B33 that is diagonal element sum is 0. So this means this implies at least one of the diagonal element is dependent. Okay, this implies at least one of the diagonal matrix one of the diagonal element is dependent. One of the diagonal elements is dependent. One of the diagonal element is dependent. So that means the total number of independent component is, therefore total number of independent component equal to total 6 minus 1, right? 1 will be dependent because this condition there is a diagonal element sum is 0. Okay, that is 5. Okay, 5 is the answer. Which option is matching, guys? Let me check. Very good question. Okay, option A is the correct option, guys. Okay, option A is the correct option. So I hope you have understood it. Okay, well, there is one more question, guys. I'm going to solve it. It's also a good question. A particle of mass m, question number 4. A particle of mass m, a particle of mass m a particle of mass 1 GeV upon c square, guys. Okay. 1 mass 1 GeV upon c square, that is giga electron volt. Okay, 1 giga electron volt per c square. Okay, a particle of mass 1 giga electron volt per c square, and its antiparticle a particle of mass 1 GeV per c square and its antiparticle both having the same speed, having the same speed v. Okay, v produce a new particle x of mass 10 GeV giga electron volt per c square in the head-on collision the minimum value of v, the minimum value of v required for this process is closest to, option A is 0.83, C, option B is 0.93, C, option C is 0.98 C, and option D is 0.88 C. Okay, so this is the question, guys. Very good question. Okay, a particle of mass m, okay, mass 1, okay, 1 GeV per c square, and its more antiparticle, both having the same speed. Okay, I would like to inform you guys, if particle has mass, the particle and antiparticle has the same mass, guys. You need to note down. Okay, I have explained that in my particle physics lecture. Okay, so they have the same mass. So so particle having mass 1, right, 1 GeV per c square, it means antiparticle has the same mass. Okay, both having same mass, they produce a new particle X of mass 10 GeV per c square. Okay, in head-on collision, the minimum value of V required for this process is closest to. So we need to find the minimum value, right? So it's a very simple question, guys. What we are going to do is we are going to use energy conservation law. That's all. Okay, so this one, this is a particle, this is going with speed v, and this is antiparticle, this is coming here with speed v. Okay, and they collide and they form a new particle. Okay, whose mass its mass is 1 GeV upon c square. Its mass is 1 GeV upon c square, and its mass is 10 GeV upon c square, right? So now what we are going to do is we are going to use energy conservation. Okay, so conservation of energy, conservation of energy, conservation of energy. Okay, conservation of energy. So we know that is gamma mc square plus gamma mc square equal to capital MC square, right? So gamma means, gamma value means root 1 minus v square upon c square, right? This is the value of gamma, 1 upon, my apologies, 1 upon. Okay, so this is going to be mc square upon root 1 minus v square upon c square. Gamma value is 1 upon v square minus c square. Okay, c square plus this is going to be mc square upon root 1 minus v square upon c square. That is going to be mc square. Now we'll put the value, guys. Okay, so this is going to be see, okay, so we'll put the value. M is 1, right? 1 1, and this one, so this is going to, we will add it. It's going to be 2c square upon root 1 minus v square upon c square. Okay, that is going to be equal to this one, mc square, right? M means, m value is given, that is 10 into c square. C square will get cancelled. Okay, this will come here, so this is going to be 2 by 10 means 1 by 5 is going to be equal to root 1 minus v square upon c square, where v is the velocity of a particle and antiparticle. Okay, and now from here we'll square it. So this is 1 upon 25, squaring both sides, 1 minus v square upon c square. So from here v square upon c square is going to be 1 upon 25 square, right? 1 minus v square upon c square. So this will come, so 1, this is going to be 1 minus 1 upon 25, right? So from here value of v is going to be very simple, that is root 24 upon 5. Okay, so root 24 upon 5 into c, guys. Okay, so from here value of very simple calculation. So so if we calculate it, so this is going to give 0.93 c, 0.93 c. Okay, so this is the speed. So this is what we need to find out. So this is the uh, minimum value of B is required. So minimum value of B speed is this one, option B, 0.93 C. Okay, so this is the answer, guys. Okay, okay, guys. Well, I'm going to stop here, guys. And also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay. And also, guys, please share my details and my lectures to the students or your friends, so that they will also be able to watch my free live lectures and they will also be benefited by it. Okay, guys, thank you. Bye now.